Hey everybody, welcome to day 2 of section 5.8. We are continuing our quest to find all of the zeros of a polynomial function. Yesterday, if you will recall, we used what's called the corollary to the rational zero theorem, which allows us to list the possible rational zeros of a function. After listing the possible rational zeros, we then used Desmos to graph the function to identify what the actual rational zeros were to that function. So today, we will encounter functions that, in addition to having rational zeros, are also going to have complex zeros. When we encounter a function that has those characteristics, we are going to also need to use synthetic division, as well as solving an equation using the square root property of equality. So we're going to take our 2 skills from yesterday. We're going to start with those and then find that there's a little bit more work to be done. So to warm up, we're actually going to find all the zeros of this polynomial function. And yes, I crossed this one out because I rewrote this 4 times and I did not want to recycle a 5th piece of paper. So we are going to find all the zeros of this polynomial function. So the first thing that we're going to do is we're going to use the corollary to the rational zero theorem, which says that we list all of the factors of our constant term. That means we have positive and negative 1, positive negative 2, positive negative 3, positive negative 4, and so on. What I will have you do now, or rather, remember, what this means is that the rational zeros of this function can only occur at these values on the x-intercept. So what I would like you to do now, please, is pause the video, graph this function on Desmos.com, and identify what rational zeros this function has. Great. Hopefully, after graphing the function, you found that the function crosses the x-axis at the 3 following locations: -4, -3, and 1. And yesterday, I wrote these all out as x equals and did not use set notation. And so today I'm going to use set notation like Mrs. Connors did in the previous section, section 5.7. Okay, so that encapsulates or reviews what we did yesterday. Listing the possible factors, or listing all of the factors for our constant term, then graphing the function and identifying which of these values actually corresponds to the zeros of the function. For our next example, one thing I forgot to mention. Sorry while I have a blank screen. Remember, this was a cubic function, so we should expect an odd number of zeros, and it cannot exceed this. And we determined that it had 1, 2, 3 rational zeros. And what that means is we're not missing any, because this is the maximum number of zeros that a cubic function can have. So remembering that, we're going to look at our next and final problem. We are being asked to do the same thing, to find all of the zeros of this particular polynomial function. Remember, okay, the total number of zeros should match the degree of the function. So the degree of this function is 4. So we should expect or anticipate a total of 4 zeros for the function. So the first thing we're going to do is what we did in the previous problem. We're going to list the factors of our constant term, which in this case is 15. So we would have positive and negative 1, positive negative 3, positive and negative 5, and lastly, positive or negative 15. So any rational zero that this function should have should correspond to one of or some of these numbers here. I'd like you to take a moment, pause the video, and graph that function, please. Hopefully, upon doing that, you noticed or observed that the graph goes through the x-axis at the values -1 and 3. But in addition to that, hopefully, we should remember that the total number of zeros should match the degree of our function. Now, we only have 2 zeros here, and we should have a total of 4. So because we have fewer zeros than the function should produce, what we are going to now need to do is use these zeros in synthetic division with this function. So you may pick either one of these values to start. It does not matter which one you pick. I happen to pick the 3 first. So the root becomes our sort of divisor in synthetic division. Okay, so remember, we're going to list the coefficients of the function: 1, -2, and so on. Multiply, add, multiply, add, multiply, add, multiply, add. Now, fortunately, this remainder of 0 should come as no surprise, because we knew that this was a 0 of this function, which means its factor should be a factor of this function, or this function should be divisible by that factor. So what we're going to do next is write the resulting depressed polynomial. And then we are actually going to use the other rational 0 as our next divisor for synthetic division. We have a leading coefficient of 1, another coefficient of 1, coefficient of 5, and then another coefficient of 5. Multiply. Oops, pardon me. Multiply, add, multiply, add, multiply, add. Once again, a remainder of 0 is what we should expect in this context, because we know that we were dealing with factors of the original function. That gives us x squared, technically plus 0x plus 5. We're going to ignore that 0x and write x squared plus 5. The last thing we're going to do here is we're going to set this equal to 0. And we're going to solve this equation. And this is where the square root property of equality comes in. So we are going to solve this equation. We're going to solve it by subtracting 5 from both sides. And lastly, we're going to take the square root of both sides. When you take the square root of both sides of an equation, plus or minus every time, we have a negative inside of the square root. So we are going to kick the I out, or poke the I out, excuse me, and leave the square root of 5. These are the non-rational zeros of the function. These are our additional 2 zeros to our original function. All right, so what we have is the original 2 zeros of our function, We then have the negative version, so the opposite of I, radical 5, and then the positive version. And so we now have 1, 2, 3, 4 zeros to match our function, which is of degree 4. I know that's kind of a long process, guys, but as always, if you have any questions when you're going through these, please feel free to reach out to myself or Mrs. Connors through the Google chat page or through Classroom. Thank you again. I hope you have a good day.